Happy Tuesday. The video for tonight was total mass, right? Total density. I think we looked at volume using cross-sectional slices, which is going to be important when the next video derives disk method, and average value. The problems that we're going to do tonight deal only with average value. I'm hoping it's going to be short. Fine, because I'm still recovering from a weekend illness, so if it's short, great. Get to go home early. Starting on Thursday, we're going to look at disk method and shell method. So Thursday will be the disk method. Tuesday will be shell method for volumes of revolution. Right, and they all are derived using the cross-sectional slice method. Right. Again, general idea is the same. An integral represents a sum, right? So if you're thinking of total, it's probably an integral. If you're thinking of anything that involves a sum, it's probably an integral. Right? So total mass, right? Sum of masses. Total density is sum of densities. Average value. Well, we're familiar with the idea of arithmetic mean, right? Sum of the values divided by the number of values you have. So we think of average value of a function. Again, right, that'd be an average value of n data points. There's a derivation in the video that goes into how you can think of summing function values and letting that go to infinity to get an average value of a function. It only breaks down to the average value of a function. One over the length of the interval times the integral from a to b of f of x dx. The absolute value of x minus 1, average value, -1 to 3, we'd have 1 over 3 minus -1 times the integral from -1 to 3 of our function. So we're going to have a quarter. Then we're going to need to split the interval at 0 because of the absolute value. Right. Remember, absolute value of x is negative x whenever x is less than 0, and positive x when x is greater than or equal to 0. So that's how the evaluation would work. Now it's just two simple integrals to evaluate. What are we going to get in that first bracket? 0. And a half plus 1. And then the second bracket looks like 9 halves minus 0 and then minus 3. That wound up being a half times 3 halves, which is 3/4.
And the first part of the previous row you just wrote, 1/2 and 1 should be, one of those should be negative. So the second one should be negative, the 1.
Yes, it should. That's 3 negatives there, which makes this negative a half. Negative an eighth plus 3, so it'll be 2/8, which is a quarter. There you go. Just factor out the quarter into 3 halves minus a half is 1. And then 1 times a quarter is a quarter. Right. Average value then of the function of that interval is a quarter. By the way, it's also guaranteed that there is a point in the interval -1 to 3, call it C, such that f of C equals a quarter. That is the mean value theorem for integrals.
Only if your function's continuous, right?
Right. But there's also only an average value if your function's continuous over the interval. If it's discontinuous over the interval, it wouldn't have an average value because you can't integrate it.
Well, you could separate it.
Right, but then you'd have like two separate intervals then. Right, because the idea is there would be, even if there's one point in discontinuity, what happens if you try to sum a value that doesn't exist?
Oh, yeah.
So that's why it wouldn't really make sense. So I'm talking about, since we found the average value, obviously there exists some C by the mean value theorem for integrals. Average value here, right, again, 1 over b minus a. We have 1 over 2 pi. Integral from 0 to 2 pi. E to -4t sine of t minus the sine of t dt. And now let's have some fun. And let's say this was a test problem, and the problem would say you're not allowed to use a calculator. One over b minus a. Right. Essentially, it's 1 over the length of your interval. So the length of the interval counts as the number of data points, let's say. Since we're not allowed to use a calculator, how would we go about finding this integral? What technique would we have to use?
The integration by parts.
Maybe. Doesn't sound very certain.
So I'm not certain.
What would your u be? Well, that's going to leave you the same problem. You're just replacing t with u at that point then. That'd be the only difference. Uh-oh. This doesn't give me great hope for the test that was due today. Shane, you said maybe. It is integration by parts. It's a product of functions, isn't it? There's actually two ways to do integration by parts here. You could write this as two integrals, distribute the e to the -4t through, right? And then you have two integration by parts problems, which I don't know about you, but once is good enough for me. What should we let our U be?
Sine t minus cosine t.
Sine t minus cosine t? I actually don't think it matters, to be perfectly honest. Just like if it was e to the negative 4t times sine t, I don't think it would matter. Or I know for a fact it wouldn't matter what you chose your u and your dv to be. Yes, I'm already in class. You can stop reminding me. I'm going to stick with what I have in my notes and go with e to the negative 4t.
It'd be easier to not do that, but
Or it'd be easier not to do that.
because then you don't have to do integrals and sine cosine. Now that they're very hard, but I think it's just a bit easier.
Right, instead, you have to do an integral with e to the negative 4t, which requires u sub.
I mean, not really. You can kind of like,
Yeah, but I'd rather do chain rule than u sub. Personally speaking. It really doesn't matter. One way isn't more difficult than the other. And so I'll challenge you to do it with u being sine t minus cosine t. Verify that you get the same answer. Because I'm almost certain it doesn't matter. du negative 4e to negative 4t. And then v, of course, would be negative cosine t minus sine t. Of course, there should be a dt attached to that du. One over 2 pi times. And remember integration by parts. uv notice I'm factoring a negative out of the v, minus the integral of v du. Again, I'm going to factor a negative out of the v, and then write that as plus the this should be evaluated from 0 to 2 pi. And then integral from 0 to 2 pi. There's another negative there. Of course there is. So that is going to stay negative. 4e to the negative 4t times cosine plus sine t. Let's evaluate that first term. Start with 2 pi. Get negative e to the negative 8 pi. Cosine of 2 pi. Sine of 2 pi. So that term's just 1, so it's just negative e to the minus 8 pi. Minus negative, now at 0. E to the 0 is 1. Cosine of 0. Right, same as 2 pi. So that entire thing will be 1 as well. So 1 minus e to the negative 8 pi is that evaluation. It's going to go ahead and factor out that 4. Oh, look. You have to do integration by parts again. Stick with your original choice. So we went u is e to the minus 4t, so we'll do mu is e to the minus 4t. I think nu is that. D nu, cosine plus sine. Right, then d mu is the same. And then we get as our nu sine minus cosine. Rewrite that as 1 minus e to the negative 8 pi minus 4 times mu nu evaluate 0 to 2 pi minus we're gonna have minus a negative, which is nice. I'm gonna factor out the 4 this time, as I see it. Integral 0 to 2 pi of nu d mu excellent. Here's the real question. Do I want to write that as a single fraction? Not yet. Again, evaluate. E to the negative 8 pi. Sine of 2 pi, 0. Cosine of 2 pi is 1. So that's going to get times by negative 1. Minus, now it's 0, well, we know it's going to be a negative 1, right? Then plus 1. 1 minus 4, -3. Negative e to the negative 8 pi plus 4e to the negative 8 pi. Plus 3e to the negative 8 pi. Right, that's just stripping that 4 through and then combining like terms. Plus 16 times that integral.
Is that not our original integral?
Technically, it's 1 over 2 pi times the integral, right? Going to distribute that 1 over 2 pi through. Write the -3 first. I just have to subtract that. Hold on a minute. That should have been a -16, right? You didn't catch me this time. You're slacking. So that minus makes that plus. And combine. Be what, 17 over 2 pi? Yes, that's what I want. Now you might be tempted to multiply both sides by 2 pi over 17. Don't do that. Remember, we're trying to find average value. We want 1 over 2 pi times the integral to equal something. We're just going to multiply both sides by 1/17. No, not 14. Not multiplied by 7. Three e to the negative 8 pi minus 3 all over 34 pi. There's our average value. that what you got with the other order?
I just didn't feel like doing more after reaching the second integration, but
Twitter. That was fun. Made me feel like we were actually doing math. E's and the pies. Like I'm back in physics. One over one minus sine theta on 0 to pi over 6. One over pi over 6 minus 0. Which is just pi over 6. Integral from 0 to pi over 6. 1 over 1 minus sine theta d theta.
it's a power rule and a chain rule.
What do you mean power chain?
It's 1 minus sine of theta all to the negative first.
Right.
So then you can,
What's your u?
1 minus sine theta is your u.
And then what the du?
Minus cosine theta.
Do you see a minus cosine theta in there?
Oh wait, never mind.
U sub won't work. That would have been nice. But sadly, it doesn't work. There actually is a special substitution to use for this. I believe it involves like tangent of theta over 2 or something like that. It's like a really obscure substitution that I just don't have time for. Clearly that integral evaluates out to root 3 minus 1. So it's just 6 over pi times that. It's obvious.
Plugging into a calculator.
Huh?
Is that plugging into a calculator?
You never tell your friends that, though. You just go, it's obvious. Or it could be the same thing with this. So you just erase all of your work and go, obviously. That's what it evaluates out to.
Same like 1 over 1.
Integral from 0 to pi over 6 of 1 over 1 minus sine theta is root 3 minus 1. Right, you just tell everyone it's obvious. You never tell them that you used a calculator. Never show your weakness.
So like, if you like plug it in a calculator with the limits, that's what it should. Oh,
The only one I actually used a calculator on. I just couldn't be bothered to look up that substitution. This one's also fun. First one that isn't 0 to something. Oh, no, second one, isn't it? The first problem also was negative, I think it was -1 to 3, right? What is the length of the interval 1 to 3? 2. 1/2 times the integral from 1 to 3. Root x plus 1 all over root x dx. You can, but this one is a more obvious substitution. Let u be the square root of x. Then what's du? We have a 1 over 2 root x dx. There's our du. Now we just have root of x plus 1 to deal with. Well, that's no problem. If u is root x, then x is u squared. Remember, we did a change of variables, so the limits of integration also change. 1 to root 3. This is why I said this one was fun. How would you evaluate that with no calculator? What technique? It also happens to be my favorite technique. Trig sub! Which one? This is a tangent substitution. Do the substitution, you get secant cubed theta d theta as the integrand. We did another change of variable, which means the limits of integration also change. When u is 1, what is theta? When u equals 1, what is theta? Which is what? What is it?
Pi over 4.
It's pi over 4. When u is root 3, what is theta?
Pi over 3.
Pi over 3. This one was nice in the sense that you actually got, nice angles. And not something like the inverse tangent of 5, which happens more often than not.
Is it okay if the bottom angle is larger?
It's fine, but in this case, it's not.
But if it was?
Yeah, that's fine. That can happen. Remember, there's no rule that says the lower limit actually has to be the smaller limit. In Calc 3, you'll learn that is the direction of integration. Right, so the standard direction you think of is left to right, but it's not the only direction. All right. Now at this point, I decide, okay, secant cubed. I'm just gonna wind up using a secant reduction. So why not just use the bloody secant cubed formula on the table? Which is number 26. One half secant theta tangent theta plus a half log of the absolute value, secant plus tangent. Evaluated from pi over 4 to pi over 6. At least here we don't have to do backward substitution. That's why we went through the effort of replacing the limits.
Not to pi over 3.
Yeah, it should be pi over 3. I don't know why I put pi over 6. I was even thinking pi over 6 originally, and I don't know why. It's going to go ahead and factor out a 1/2. Secant of pi over 3. Tangent of pi over 3, we already know. It's root 3. So that first evaluation is 2 root 3. I'm now just going to evaluate that at pi over 4, get it out of the way. What's secant of pi over 4? Which simplifies to what? Which is just root 2. That is where the alternative form of tangent of cosine of pi over 4 comes in handy. Cosine of pi over 4 technically 1 over root 2. We just write it as root 2 over 2. Same thing, we rationalize it. Tangent of pi over 4. Yep, so we just get root 2. Don't need the absolute values. Really went through this. Secant of pi over 3. It's 2. Tangent of pi over 3. Root 3. Then minus the log. Secant of pi over 4 is root 2. Tangent of pi over 4. It's 1. Distribute that half through. And there is your average value. Or if you really wanted to, you could write the half log of that as log of the square root of that entire thing.
So initially, when we started, there was a square root in the numerator and denominator. Could you have moved it to the outside and solved it differently?
I doubt it. I highly doubt it. Right, because then what you would wind up with is essentially the square root of 1 plus 1 over x. Which doesn't help you at all. So the best option here is root x. So average value is very simple, right? Especially if you're going to be allowed to use a calculator, which you are. You don't have to go through any of that. I just wanted to have a bit of fun. Question on average value of a function. I really wanted to, I could start this. Feeling generous. Is it next week or the week after World Baseball Classic starts soon? So I'm in a good mood. Plus the first Phillies game is on Saturday, so I'm in really nice.
I know what make it. This is a very easy quiz. Oh, okay. Like someone I had last semester come in sporting Yankees gear. That is not gonna earn me papers.